Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 28. Let's get started. We're going to use what we noticed about adding equivalent expressions to solve the following system by elimination. Okay, well, elimination means that we're trying to get rid of one of these variables. If I can get rid of the x or the y, then I can solve for the one that's left over. So in this system, I can see that my y's are one's positive and one's negative. One's a -5, one's a +5. If I combine these two equations, those would go away. They would be eliminated, and I would just have x's left. So that's what I'm going to do. I'm combining like terms. I'm combining these two equations. So in order to do that, I get 6x plus 2x. I'm just going to add these two positive x's together. And 6x and 2x is 8x. And then a -5y and a +5y, that's 0. That goes away. And then I have a +21 and a -5. That's a +16. So 8x equals 16. And then I can multiply by a reciprocal. And when I do that, I get x equals 16 divided by 8, which is 2. And now that I have that, I can substitute my value for x into either of these equations and solve for y. So I'm going to do that. I'm going to use the positive y there. So this one is 2 times x, well that's 2, plus 5y equals -5. So that gives me 4 plus 5y equals -5. And then I isolate the y, subtract 4 from both sides. That gives me 5y equals -9, and then multiply by reciprocal. To balance the equation, we get y equals a -9/5. Y equals -9/5. So that's my ordered pair. X is 2, y is a -9/5. That is the solution to this system. All right, let's do another one. Let's see. I want to combine by I'm going to use elimination again. So let's see. The x's, if I combine, they don't go away. If I combine the y's, they don't go away. So I need to manipulate one of these equations, and I need an equivalent equation. And I can see that if I multiply this top equation by 2, that will give me a -4x. And a -4x and a +4x, they would eliminate. So let's do that. We're going to use the distributive property. 2 times -2 is a -4x. 2 times 7y is a +14y. And 2 times 5, that's 10. Okay, so there's our new equation. Let's get rid of that one. And now I can put them together. So this +4x and -4x, that cancels. Okay, the x's are eliminated. I have a -2y and a +14y. That's a +12y. And then a +14 and a +10, that's a +24. If I multiply by the reciprocal of 12, then I find that y equals 24 divided by 12, that's 2. So y is 2, and then I can use either equation, doesn't matter which one. I'll use this one. Okay, so this is 4x minus 2 times y, which is 2, equals 14. And that's 4x, -2 times 2 is a -4, equals 14. And I'm going to add 4 to both sides. 4x equals 18, multiplied by reciprocal. And the x's, the 4's cancel. X is equal to 18/4, which would be 9/2. So my ordered pair, the x value is 9/2. The y value is 2. All right, let's try another. Let's see. I would like to change this 3 into a 7, but I can't do that. I'd like to change this 3 into a 5, but I can't do that. So that means I need to change both equations into some common multiple. So I'm gonna work on the y's. I think I'm gonna work on the y's, and I'm gonna make them both 15. So that means I would have to multiply the top equation by a 3, and I'd have to multiply the bottom equation by a 5. That will make both of my y's 15. But remember, I want one to be negative and one to be positive. So I'm going to choose a negative 3 on top. All right, and then I'm going to just use the distributive property, create two equivalent equations, and then see if I can eliminate. So negative 3 times 7x, that's a negative 21x. A negative 3 times a negative 5 is a positive 15y. And that's equal to a negative 3 times a negative 2, that's a positive 6. On the bottom equation, 5 times 3x, that's 15x. 5 times negative 3y is a negative 15y. And 5 times 7 is 35. So now I can combine them, and I will see that my y's will cancel. They're eliminated. Negative 21x and a positive 15x is a negative 6x is equal to a 6 plus 35. 6 plus 35, that is 41. So now I can multiply by the reciprocal of negative 6. That's negative 1/6. Multiply by negative 1/6. And we get x is equal to a negative 41/6. That's my x value. Then I can plug that back in and solve for y. And I can use any of my equations, including the first ones, before I change them. So I'm going to do that. 3 times a negative 41/6 minus 3y equals 7. All right? So let's see. 3 times a negative 41/6. Well, I'm going to simplify before I multiply. Let's do that first. 3 goes into 3 once. 3 goes into 6 2 times. So that's negative 41 halves. Negative 41 halves minus 3y equals 7. And now I want to add 41 halves to both sides. And that means I'm gonna change my 7 into halves. That would be 14 halves. So let's think of this as 14 halves plus 41 halves. Okay, and then 14 halves is 14 plus 41. So let's see. We've got negative 3y is equal to 41 and 14 is 55 halves. 55 halves. And then I can multiply by the reciprocal of negative 3. That's a negative 1/3. Multiply by negative 1/3. And we get y equals 55 times negative 1. That's a negative 55 over 2 times 3. That is 6. So the y is negative 55/6. So there's my ordered pair. The x value is a negative 41/6. The y value is a negative 55/6. All right. Moving on. Solve each of the following systems. Each of them has a solution. Determine the solution by eliminating one of the variables. Okay, so using elimination again. And this one's nice. I see it's already set up. If I combine, they're gone. So negative 7 and a positive 7. That's 0 y's, so that's good. Then I have a positive 6 and a positive 3. That's 9x. And that's equal to a negative 10 and a negative 8. That's a negative 18. And then multiply by reciprocal, I get the 9's to cancel. X equals a negative 18 divided by 9. That's a negative 2. Okay, and then use either equation. Let's use the bottom one. 3 times x, which is negative 2, plus 7y equals negative 8. 3 times negative 2 is negative 6, plus 7y equals negative 8. Then I'm going to go to work on isolating the y by adding 6 to both sides. That gives me 7y equals a negative 2, and then multiply by reciprocal. And when we do that, the 7's cancel. Y is equal to a negative 2/7. So my x value is negative 2. My y value is negative 2/7. And that's the ordered pair, the solution to my system. Let's try this one. Let's see. Changing the 4 into a 9 would not work, but I can just multiply the top by 5. That will give me 5x, but I want it to be negative, so I'm going to multiply by negative 5. And if I do that, we'll get a new equation, an equivalent equation. Negative 5 times x is negative 5x. And that allows my x's to be eliminated. Negative 5 times a negative 4 is a positive 20y. And then negative 5 times 7, that's a negative 35. Okay, now we can combine. That one's gone. 5x and negative 5x cancel. 9y and 20y gives us 29y. And a negative 35 and a positive 6 gives us a negative 29. And then I multiply by reciprocal. And the 29's cancel. Y equals a negative 29 over 29. That's a negative 1. So my y value is a negative 1. And let's use the top equation this time. X minus 4 times y, which is negative 1. That's equal to 7. So we have x. And then negative 4 times negative 1, that's a positive 4, equals 7. And then subtract 4 from both sides. And we get x equals 3. So my ordered pair, x value is a 3, y value is a negative 1. That's the solution to the system. Okay, let's do one more. Let's see, 2 times 2 is 4. That's not going to work. And 3 times 2 is 6. That's not going to work. I need to change both equations. Let's get rid of the... let's get rid of the x's. Let's change both these x's into 6's. That means I would multiply the top by 3, the bottom by 2. That'll make them both 6's, except I want negatives, so I'm going to use the top one as my negative so that it changes these negatives into positives. Okay, I could choose either one. I'm just trying to make this as easy as possible for myself. So let's see what we get. We get negative 3 times 2x, that's a negative 6x. A negative 3 times negative 3 is a positive 9y. And a negative 3 times negative 5 is a positive 15. So there's my first equation. 2 times 3x, that's 6x. 2 times 5y, that's 10y. And 2 times 1, that's 2. Now we can combine them. My x's will be eliminated. I get 19y equals 15 and 2 is 17. Okay, multiply by reciprocal, and the 19's go away. We get y equals 17/19. Ugh, that's ugly. All right, and then I'm going to go back to one of my original equations. This time I think I'm going to use the second one. So I've got 3x plus 5 times y, which was 17/19. And that's equal to 1. All right, so I have to figure out what 17/19 times 5 is. Well, that's 85/19. So 3x plus 85/19 equals, I'm going to change this 1 into 19/19 because I know I'm going to have to subtract. I'm going to have to subtract 85/19 from both sides. That gives me 3x is equal to, well, let's see, 85 minus 19 would be 66. So this is a negative 66/19. Okay, and then I'm going to multiply by reciprocal, and that gives us x equals, well, I can simplify before I multiply, so I'm going to do that. Let's see, 3 goes into 3 once, and 3 goes into 66 22 times. And so I get a negative 22 times 1, that's negative 22, over 19 times 1 is 19. So that's my x value. And the ordered pair is negative 22/19, and the y value is 17/19. And that is the solution to the system. All right, that is your lesson today. I hope that helps. See you next time.